Greetings, Algebra 2 students. I appreciate you finding time to get your notes taken care of. Today we're going to be taking a deeper look at the first conic section that we have discussed, and that would be the circle. So please copy down your title, Equations of Circles, as well as the objective. And our objective for this day is to learn the standard and general forms of equations of circles. Now, as you can gather from that statement right there, there are two particular different forms of equations of circles. One of them is very easy to read, the other one not nearly so much. Okay, so we will have to learn to get back and forth between the two different equations, and that's going to be the focus of our lesson today. Okay, now the general equation for a circle. We already saw this guy in the last unit, or the last lesson, and that was x squared plus y squared equals r squared. And this is kind of the unit circle, unit conic section for the circle. Okay, but as we have seen through recent units, there are, of course, a lot of adjustments that can be made from the unit or parent version of a particular graph. So more specifically, a circle is going to follow the equation, and here come some of our old friends. We have h and k showing up in the equation now, and the equation is x minus h quantity squared plus y minus k quantity squared equals radius squared. Okay, and of course, as I just said, r represents the radius. Okay, so please take note that the r value is squared. That's a number being squared, so that's going to be a different number. Keep that in mind when it comes time to figure out how big your radius is. And the center of our circle is located at h comma k. Now, as always, okay, these values are built into the formula. Okay, so one major difference between this equation and the ones we've been seeing recently with the parent functions is k is built in as negative as well. Okay, but this basically gives us the only two pieces of information that are going to be needed in order to graph a circle, and that is what is the center of the circle and how far does the radius reach out. So when we are in this particular format, the equation of the circle or the graph of the circle is very easy to understand, and this is what is referred to as standard form of the equation of a circle. Okay, standard form. Sometimes you will run into this called center radius form, and specifically they call it that because it does provide you with the location of the center and the length of the radius. Okay, so standard form is going to be the easier of the two forms for us to work with, so we will want our equations in standard form if we can help it. Okay, but first let's take a little bit closer look at standard form before we get to the other format. Okay, so let's say we're looking at an equation like this one. You have x minus 3 quantity squared plus y plus 2 quantity squared equals 36. Now, once again, the only two things that you need to know about a circle are these two things. You need to know where to begin. That's called the center. Okay, circle has a center, not a vertex or any other crazy language like that. It's called a center. And then, of course, the measurement that reaches out from the center to the circumference of the circle is referred to as its radius. We need to know these two values. Once we know these two, we'll be able to graph everything that we need. Okay, so let's look at the equation and see if we can determine where its center is actually at. Now again, remember that there are supposed to be negative signs built into this equation for x minus h and y minus k. Well, on the x value there, you can see that the minus sign is present inside of that binomial. That means 3 did not do anything to change the sign, so that must be a positive 3. In the y binomial, okay, the minus sign is not there, which means the 2 must have come equipped with its own negative, and the two negatives became a plus to make it read like y plus 2. So we should have an h value of positive 3, a k value of negative 2. That puts our center at 3, negative 2. Okay, so we would go to our graph and we would put a point at 3, negative 2 if we were graphing. Okay, now we need to know from there how big is our radius. Okay, well obviously the constant sitting over there is 36, but keep in mind that is r squared. Okay, so if we want to figure out how big r is, we would have to take the square root of 36, which of course would be 6, radius of 6. Very simple concept. We'll do look at one more just to make sure we got it. Okay, let's say we're looking at a circle, and we should know it's a circle because our coefficients of x and y, they are both the same sign, they are both the same value, and we are both squared on the x and the y. Anyway, it's a circle, x plus y, quantity squared plus y squared equals 29. Same two questions are going to be prevalent all through the discussion of circles. Where is the center and how big is the radius? Okay, so let's look at the center. Okay, x minus k, or I'm sorry, x minus h is what it should say. So that must be a negative 7 sitting there for h. And what about the k value? There's nothing being added or subtracted to y, which is fine. That means our k value is 0. So our center is at negative 7, 0. As for our radius, okay, we have a constant over there of 29. That is r squared. To get r, we would have to take the square root of 29, and 29 is a prime number. Okay, so we are looking at the square root of 29. Most people don't know how big that is, so when it comes time to graph, we would probably go to our calculator and ask the calculator how big square root of 29 is, and it's most likely in the ballpark of about 5.2, maybe 5.3, and then you could use that decimal point to measure outward from your center. Okay, now let's actually get them into the graph this time. Okay, here's one more equation, x plus 2 quantity squared plus y plus 1 quantity squared equals 25. Okay. Well, same questions are going to be important. Where is the center and how big is the radius? Hopefully, looking at the equation from the first two examples already, you should be able to very quickly decide that your center is located at negative 2, negative 1. Okay, so you have a coordinate there. Your coordinate turns into a point, and there's your point at negative 2, negative 1. Now, how big is the radius? 25 is r squared, so if we take the square root to get our radius, we have a radius of 5. Okay, now when it comes time to graph this, you don't have to be absolutely perfect with your graphing of your circles. I know we're not perfect artists, we can't draw perfect circles, but what I do expect you to do is to take this radius value and measure basically north, south, east, and west of your center point the right number of units. So from your center at negative 2, negative 1, we ought to be able to go straight up that grid line 5 units, straight left on the grid line 5 units, straight down 5 units, straight right 5 units, and we ought to be able to plot those 4 positions based upon how large our radius was. Okay, now from here, just do the best that you can to make a circular type object. Okay, I know it's not going to be perfect, but I do expect to see on your graphs your center point, your north, south, east, and west values plotted correctly based upon how big your radius was, and then a rough sketch of a circle from there. Okay, now on to the other format for the equation of a circle. This one is considerably harder to work with. As such, you can probably expect that they are going to use this format to make sure you understand what's going on with the circles. Now, we've already talked about the general form of the quadratic was this big guy. Okay, and basically what we're talking about is when our circle is in this format rather than the standard form that we just saw, well, Well, this is very difficult to graph from. I'm not gonna tease you and tell you it's easier than it actually is. This is hard to graph from it. Okay, so what we're gonna do is we're gonna learn to get around this equation. We're gonna get out of general form and get into standard form. Okay, but in order to do that, we are going to need to brush up on a skill from earlier this year. Some of y'all enjoyed it, some of y'all did very well at it, and the skill is completing the square. Okay, but there is a little bit of a catch to completing the square in a circle, and the catch is going to be that sometimes you may have to complete the square twice in the same problem in order to get the equation done, and you'll see what I mean by that here shortly. Okay, now before we get into it, let me give you a basic rundown of completing the square. It's been a number of months since we looked at it. Okay, so I'm going to give you basic step by step. If you need a further explanation, go ahead and look back. And in Modo, you ought to be able to get all the way back to those files and watch the video. It was way back in the factoring unit. Anyway, the basics of completing the square. Here is your step by step. Okay, the first thing that we do is, since we basically said the problem is unable to be factored or understood in the format that it's written in, we move the constant to the other side of the equal sign. That's still a reasonable first step to take. So get the constant out of the way. The next thing we're going to do is we are going to look at the coefficient of the first dimensional variable. Now, this can get a little bit confusing at this step because you might have more than one first dimensional variable in your problem, which is why I said you might have to do completing the square twice, once for your x's and once for your y's. Okay, but pick a first dimensional variable that you would like to complete the square on. Okay, the completing the square process is to take that coefficient, half it, and square it. This new value that you just ended up with is going to have to be added onto both sides of the equal sign. It will not be a subtraction problem. It'll always be addition, because anytime you square a number, you always end up with a positive value. Once you have added this new number in, you should have a second dimensional variable, a first dimensional variable, and a constant that all belong together. This trinomial will factor into a binomial that can be rewritten as a binomial that is squared. And as I've already said a couple of times, it may be necessary to repeat this procedure one time for the x values to get that binomial squared, talking about x, and then a separate time to get your binomial squared, talking about y. Okay, so what we're going to do now is we're going to take a look at an equation that is coming out of general form and see if we can't get it into standard form. Okay, so here's an equation. Hopefully from our discussions yesterday, you can quickly identify that this is in fact a circle. We have x squared and y squared. The coefficients both match, and so do their signs. So this is definitely a circle. Okay, but if we are given instructions to graph this equation, not only do we not know where to go in the graph to place the center, we really don't have any way of knowing what the radius is. Okay, in the general form that you're looking at now, the constant, that -4, that guy is not the r squared like it was in the standard form. You've got to actually get to standard form before you can read the constant that way. Okay, so let's see if we can't get it into standard form. Now, as we said, our first step for completing the square is we're going to get the coefficient or the constant out of our way. So that -4 does not need to be over here interacting with all of our variables. Okay, so the first thing we should do is move it to the other side, and you might find it more helpful to reorganize the problem as I've done there. Put all of your x terms together, put all of your y terms together, because when you complete the square, we don't want to get confused about which terms are participating with which other terms. Okay, so I put the x's together and I put the y's together, and now it's time to get the 4 out of the way. So I'm going to add 4 to both sides. That'll obviously eliminate the constant on the left side, and the right side will no longer have a 0. It'll have a positive 4. Okay. Now, what we're going to do is we're going to complete the square one variable at a time. Typically, I just go alphabetically here, or left to right, whatever you want to call it. So I'm going to start by focusing on the x values. Okay. Now, remember what you do is you take the coefficient of the first dimensional term, which is the -2 in front of the -2x. We're going to take half of this term, and we're going to square it. So I took the 2 from in front of the x, I have halved it and squared it. Of course, half of 2 is 1, and squaring it is going to be, obviously, 1 squared is 1. Okay, so 1 is the value that is going to get added in to both sides of our equation here. Okay, so adding a 1 to both sides is going to give us this. Okay, now please notice where I placed the 1 inside of the equation. That was the result of completing the square for the x values. So I absolutely want that to be there with the x values. Okay, and now what we need to do is we need to repeat the process for the y values. Okay, so I'm now looking over at the y terms. The first dimensional term is the -4 y to the first. Okay, so again, we're going to take that -4, we're going to half it, and we're going to square it. Okay, so this is one of those that actually works out kind of neatly. If you take a 4 and take half of it, that's 2, and if you square a 2, it gets you the 4 right back. So it's kind of neat the way that works. But anyway, 4 is the result of the completing the square process, and this value will need to be added into both sides of the equation. Okay, so again, this is the result of completing the square for the y terms. So I am going to place this into the equation there with the y terms. Now the constant that has been continually changed due to the completing the square term over there is now a 9. Okay, now what we have is we have this new term, or this new value, or new equation, pardon me, x squared minus 2x plus 1, that's our x, y squared minus 4y plus 4, that's our y, and this is all equal to 9. Okay, now the reason we've done this is because we have created two perfect square trinomials. Okay, and that means that these three x values can be combined into a binomial to the second power, and the three y terms can be combined into a binomial also to the second power. Now, if you will remember, okay, the first term, okay, of the binomial, okay, here we go, same information, I just turned the page, okay, there's the binomials being squared. The first term of each binomial is the result of the square root of the squared term. So obviously our first term for the x's is going to be x. The square root of x squared is x. And our first term for our y binomial is going to be y. The square root of y squared is going to be a y. The trail term in the binomial is the result of the square root of the constant that's associating with those terms. So for the x binomial, the square root of the constant, which is 1, square root of 1, is going to be a 1. So our trail term in our red binomial there is going to be a 1. And for the y's, square root of 4 will be a 2. Now also keep in mind that the sign between those two terms in each of the binomials, that sign comes from the b term, the first dimensional term. So in the x's, that negative in front of negative 2x there, that's going to mean our binomial is going to be subtraction. Over on the y binomial, again, the negative in front of the 4y, that negative 4y is going to mean also subtraction for our binomial. Okay, so the end of that long discussion is square root of x squared is x. Okay, the minus from in front of 2x gives us a minus, and the square root of 1 is 1. So our binomial is x minus 1 quantity squared. On the y's, square root of y squared is y. The minus comes from the y to the first term, and the 2 is the square root of 4. Okay, so you got y minus 2 quantity squared. And in this step, nothing is happening over to the right side of the problem with the constant. We are simply finishing off the completing the square term by turning our binomials into perfect squares. Once you got to this point, you should be pretty much home free, so we can go straight to the graph. Now, where should our center point of our graph be positioned for our standard form of our equation of our circle? Okay, our center should be at 1, 2. Okay, so there is our plot. And how far should we measure out north, south, east, and west from this center point of our circle? Our radius this time is going to be 3. The square root of 9 is 3. So we ought to be able to put these 5 points into our graph and then just do the best you can to sketch in the rest of the circle. Okay, now obviously it's going to take a little bit of practice on the dual completing the square. It's a lot of steps in there. Okay, but if you did what you needed to do back in the day and learned how to complete the square, then this ought to be really very simple for you. Some of you are going to need a little bit of extra time to brush up. Anyway, that is where we are at for today. I appreciate you finding time to get your notes taken care of, and I will see you in class.